All right, guys, page 2 of the review packet. First question, when is the function decreasing? As I start my graph, I notice that the first chunk of it is decreasing. From here to here, we're decreasing. I need the x coordinates. From here to here, we're decreasing. So when I count that, that is -6 to -3. Decreasing and increasing, always get brackets. I need every place the graph is decreasing, so now I also need this chunk of the graph. From here to the end, that whole piece is decreasing, so I need from 2 all the way to 6. Those are x coordinates, and they get brackets. When does f of x equal 0? That means when does y equal 0? So you know that when it's y equals, we draw that dotted line on our graph, and I want to know, when does my graph cross the dotted line I just drew? So I cross right here, here, and here. When x equals -5, -1, and +5. If you'll recall, those are also called your x-intercepts. Those are also called your zeros. All that means the same thing, okay? How many solutions are there to f of x equals -3? That means y equals -3. So I go down 3 on my y-axis. 1, 2, 3. I draw my dotted line. Now it's asking for how many solutions. So all I need to know is how many times does the graph cross the dotted line? 1, 2, 3. There's 3 different spots where my dotted line intersects the graph. That's it. I don't care where it's happening, just that there's 3 of them. Here's a big one. When is f of x greater than 0? That means that my function is positive, therefore above the x-axis. So if I'm looking at my graph, I want to know all the parts of my graph where I'm above the x-axis. So I'm looking at this piece here, right there to there. X coordinates. That is -6 to -5. When x is -6, my graph is above, it gets a bracket. When x is -5, I'm on the x-axis. That does not count. I need to be above, so it gets a parenthesis. Now, another chunk of my graph where I'm above the x-axis is this right here. That is from -1 to 5. -1, is it above the x-axis? No, parenthesis. 5, is it above the x-axis? No, parenthesis. What is the absolute minimum? That means I need the lowest point on my graph. Both of these look pretty low. 1, 2, 3, 4. 1, 2, 3. Those are both down 4. So that is my absolute minimum when y equals -4. What is the absolute maximum? The highest point on my graph is right here. 1, 2, 3, 4, 5, 6. So that's y equals 6. State the coordinate of the turning points. Okay, I follow my graph. Decrease, decrease, decrease. Right here, I turn around and start going up. That's where I turn from decreasing to increasing. That is the turning point. That is the coordinate, -3, -4. Now, on my graph, I'm increasing all the way up to here, and then I turn around again. So that is my other turning point. That is the point 2, 6. Okay, when is the function negative? That means when am I below the x-axis? That's those 2 chunks. I've got this little V shape and then this little curve right here. So I want to check from here to here. So my x coordinates are -5 to -1. When x is -5, am I below the x-axis? No, parenthesis. -1, below the x-axis? No, parenthesis. I also need this little chunk, which goes from here over to here. So that is from 5 to 6. When x is 5, am I below the x-axis? No, parenthesis. When x is 6, am I below the x-axis? Yes, that's a bracket. Okay? When is f increasing? This is the opposite of question number 1. When is my graph increasing? When the graph is going up. So my graph is increasing from here all the way to here. So I need to list the x coordinates from here to here. That's the part of my graph where I'm increasing. Increasing always gets a bracket, -3 to 2 with a bracket on the end. State the coordinates of all relative max and mins. Here we go.